Good morning, friends. My name is Mohan Singh, and how are you? I hope you are all are well at your home in this situation. Now you are in second year, third semester. You will study in this semester a subject, digital system design. This subject I will teach you. And before starting this subject, first of all, I will tell you or I will introduce about the utilization and importance of this subject in your real life. So this digital system design, before this digital system design, first of all we understand the system is of two types. One is analog system, and the second other is digital system. In analog system we use analog elements like resistor, inductor, capacitor, diode, transistors and OP-amp, operational amplifier. And this system having analog circuits, and this system will work upon analog signals, only upon analog signals, and this system voltage vary through the given range. And for example, signal generators, power supply, radio frequency transmitter, receiver and electric motors, etc. There are so many drawbacks or shortcomings of this analog systems. That's why we go further for study a digital system, because there are so many advantages over a analog system. Here we use digital elements like logic gates such as NOT gate, AND gate, OR gate or combinations flip-flop. This system having a digital circuits and works upon a digital signals with two discrete levels, that will be 0 or 1. That will be 0 or 1. There are two levels only, 0 or 1. The digital system will work upon 0 or 1. So this digital circuits, also known as switching circuits or you can say logic circuits, and this digital system is further divided into circuit design, logic design and system design. Finally, whenever you go to design a system, before to design a system you must have to design a logic circuit. Before this logic design you have to design a circuit. So in this circuit design we will study how they are connected, how the components are connected to form a gate. And the logic design, under the logic design we will study about the interconnection of logic blocks to perform a specific task such as flip-flop and logic families. These are the logic design part. And the finally is the system design, in which we break the overall system into subsystems so that we can perform a specific task. And this circuit design is further divided into two categories. One is combinational circuit and the second one is sequential circuit. What are the combinational circuit and what are the sequential circuit? In combinational circuit, your system output, this is your system, and the output of this system, this output of this system is depend upon only present input. The output, the circuit in which the output of the circuit is depend upon only a present value, only a present input. that circuit is known as a combinational circuit. Like adder, subtractor, comparator, multiplexer, demultiplexer, encoder, decoders, sequence generator, clock generator. These all are the combinational circuit. In these circuits, the output of these all circuits is depend upon only the present value of the input. Does not depend upon any other value. In other way, the sequential circuit. The sequential circuits are those circuits in which the output is depend upon the output of these sequential circuit is depend upon the present input value as well as the past value. Past value means previous value. Sequential circuit, in sequential circuits output will depend upon present input as well as the previous input, means the past input. So these circuits having the output depend upon two values, present input and past input. So that's why these are the sequential circuits. And the difference between combinational circuit and sequential circuits are these circuits having no memory, and the sequential circuits with memory. And the one previous value will store in memory, and the output will depend upon the input present and also will depend upon this previous value stored in this memory. So in sequential circuit there will be a memory, in combinational circuit there is no memory. So this is the basic difference of combinational and sequential circuit. Now I will tell you the syllabus content of your this digital system design. So in this subject you will study the unit 1. So this part having unit 1. Unit 1. In this unit 1 you will study the introductory part of a digital system and also the number systems and logic gates and also the logical expression minimization. So in this you will study unit first of your digital system design. After this you will study in unit 2. This is unit 2. Unit 2 in which you will study combinational circuits. Combinational circuits in which the output of circuits will depend upon only present value of the input. So like adder, subtractor, comparator, multiplexer, demultiplexer, encoder, decoder, sequence generator, clock generator. And in unit 3, so this is your unit 3. This is your unit 3. This is your unit 3. In unit 3 you will study about a sequential circuit in which you will study a basic element of storage memory. The basic element of storage memory, that is flip-flop. How to store a bit, a single bit you can store in a flip-flop. So you will study here the memory part, flip-flop. Under this flip-flop you will study so many flip-flops like SR flip-flop, JK flip-flop, master slave, JK flip-flop, D-type flip-flop, T-type flip-flops. After this study you will also study the conversion of these flip-flop from one flip-flop, how to convert, how to find another flip-flop with the help of a given flip-flop. So after that you will study counters, how to design a counter with the help of these flip-flop. Flip-flop is a basic element. Using this flip-flop, you can design a sequential circuit like counters, registers, memories. So you will study unit 3 sequential circuits. Under this, once you have know the sequential circuits, after that in unit 4 you will study the logic family. This is your unit 4. This is your unit 4 logic family. So under this unit you will study mainly 3 logic families. There are so many logic families, but you will study only 3 logic families: TTL, transistor logic family, ECL and CMOS. In this these first 2 are bipolar, and the last one is unipolar. And TTL is saturated. Bipolar logic family is divided into 2 categories: saturated and this is non-saturated. So what is the meaning of saturated and non-saturated? We will discuss in detail under this unit. When we will study this unit separately, we will go in deep what is the meaning of saturated and what is the meaning of non-saturated and what is the parameters upon which we will design a logic family. And finally we will discuss a unipolar, in which we will discuss a CMOS family. So this is a unit 4 under which you will study about a logic family. Logic family means a group of IC fabricated to perform a specific task having the same labels, referred as logic family. So after discussion of this unit 4, you will go for study unit 5. In unit 5 you will study peripheral devices. Peripheral means how you convert a digital signal into a analog signal. You need a converter, that is digital to analog converter. After a digital processor, you will get a output in the form of a digital, and that time you will need to convert a digital signal into analog signal. And before this, if you want to go to digital processor, first you need a analog signal into a digital signal. So that is the analog to digital conversion. So under this unit 5 you will study how to convert a digital to analog signal and analog to digital signal. What is the need and what is the impact of this unit 5? Let's know. I will tell you a digital system. What is a real digital system? A real digital system having a digital processor. This processor will work upon a digital signals. In real world, everything is analog. In real world, everything is analog. If you want to analysis, if you want to design, if you want to go to find any information, so first you have to convert your analog signal into a digital signal. So now you have a analog input signal that is given by a, for example, a camera. Camera will take a analog signal, and this analog signal having so many noise, and we will remove using filter. After this, we will apply this analog signal to a converter, that is a analog to digital converter. Before applying this digital processor required a digital signal. So before applying, you have to convert this analog signal into a digital signal using this analog to digital converter. After this, you apply this signal to a digital processor. Before this, you have to filter the signal, and digital processor will process whatever you want, and after you will get a output in the form of digital. Now again you have to convert this digital signal into a analog signal. So now again you have to need to convert using a digital to analog converter, because of the output will be a analog. The analog means this is the application. What do you want to use your output signal? This is the application. Application output signal is in the form of analog. So this is the digital system. In real world, everything is analog. That's why we study this unit 5, under which we will learn how to convert an analog signal into a digital signal, and how to convert a digital signal into analog form, so that we can understand better what is the meaning of a signals. So this is the syllabus scenario of your this digital system design. Now I will tell you the utilization of this subject in your real life. Suppose whenever if you want to design a system, you will need this digital system design. Without this subject, you can't design any system. In your project, final year project, you will need this subject. Whenever you will design a system, you will need this subject. This subject is very important, very important for you, because of from the point of view of project aspect, from the point of view of any competitive examination like GATE, IES. So this subject is very important for you. So this is a little bit introduction about digital system design. What is the meaning and what is the importance? What are the utilization of this subject? I hope you can understand better before starting the subject. So this is the digital system design subject you will study in this third semester, and this subject I will teach you. Now this is the whole concept of your syllabus contents. So now I am going to end this video. So finally, thanks for watching my video.